'Cause I'm really in love with you when I'm looking at pictures of you.
In this video, we're going to talk about the finding the area between two curves. So I'm going to share all of my learnings about finding the area between two curves. All we need to do is to find the difference of integrals. In this graph, all we need to do in order for us to calculate the area between the two curves or functions is to subtract the total area of functions with a smaller area. The formula for this example is the integral of f of x minus the integral of g of x as a approaches to b is equal to the area we want. So as you can see here, this is a and this is b. This is the area we want to get. So in order for us to get this, all we need to do is to get the area of this function, of the bigger function, and then subtract the area of this smaller function in order for us to get the area we want. There are two cases in solving for the area between two curves. In the first case, it is finding the area of the curves between the two curves with respect to x, and the other is with respect to y. If the graph, if our graph if we are finding the curve which is respect to x, all we need to do is to remember that the curve must show an upward and downward curve. While in solving for the other case, the area between the two curves with respect to y, we should always remember that the curve should show a left curve and a right curve. So here in this first case, the area which is higher than the other is the function which is greater than the other, while here is the curve which is located to the right side is greater than to the left side. So here is one example. Find the area enclosed by the following two functions. Y is equal to square root of x and y is equal to 2x minus the square root of x. So the first thing we do is to graph the function in order for us to see what we are dealing with. After that, we need to convert the function to its vertex form by completing the squares. Then we have to find the limits by getting the x values where the function intersects. We need to set the function equal to each other. So this is our example. This is the problem. We are given y equals x squared and y is equals to 2x minus x squared. So this is our graph. Now we have here is to find our limit. In order for us to find our limit, we need to set the function equal to each other. So 2x minus x squared equals x squared. We have x is equals to 0 and x is equals to 1. The next step to solve for this is to find the greater function. Since we already know the limit of the function we will use it to find any value between 0 to 1 to find our greater function. Now that we have our limit which is 0 and 1, we will get any value between these numbers in order for us to get our greater function. So our function is y is equals to x squared and y is equal to 2x minus x. So I will be using in this problem 1/2. Y is equals to 1/2 squared and y is equals to 2 times 1/2 minus 1/2. So here is the result. Y is equals to 1/4 and y is equals to 1/2. Since 1/2 is bigger than 1/4, our higher function or greater function is y is equals to 1/2. So it makes sense because as you can see in the first, the higher point in the graph shows that it is the curve of the function y is equals to 2x. Then last, solving for the area using the formula. Now that we have the limits and the greater function, we can now proceed to the formula and solving it. A is equals to the integral of 2x minus x squared dx as 0 approaches to 1 minus the integral of x squared dx as 0 approaches to 1. So this is now integral of 2x minus x squared dx as 0 approaches to 1. We can simplify it as integral of 2x minus 2x squared dx as 0 approaches to 1. Then we now integrate it. The result will be x squared minus 2x cubed over 3 as 0 approaches to 1. And then we will going to evaluate this by setting x is equals to 1 and x is equals to 0. X is equals to 1 equals 1 squared minus 2, 1 cubed over 3 is equals to 1 minus 2/3 or equals to 1/3. Then evaluating it by setting x is equals to 0, 1/3 minus 0 is 0. So our final answer for this problem is 1. That's all and thank you for listening.